Hi and welcome to this SimplyMaya tutorial on lighting. What we're going to do in this video is that we're going to take a look at Maya's different light types, how to control them and when to use them. We're going to look at light effects, which can also be useful in dynamics. We'll go through the basic shaders, and for this part here I'm just going to show you how to get yourself set up with lights. So first of all, you want to make sure you're in the rendering menu set always when you're working with lights. Also, you want to have your rendering shelf open, and if you look here, we've got our basic light types. We've got a node for creating a camera, some basic materials, and some renderers and render settings. So if you want to, you can always hide your shelf. Just go to Settings, Preferences, and under UI Elements, you can just turn your shelf on and off. Should you find that you're not using it, you might want to switch it off. I'm going to leave it on for this tutorial. So for now, I'm just going to show you how to create lights. If you would hide your shelf, you can also create lights under the Create menu. And here we can see we've got ambient, directional, point, spot, area and volume light. So we're going to be focusing mainly on the spotlight, as it's the best multi-purpose light and it's quite easy to use. So now we go in smooth shade, our viewport, and we're going to go into lighting mode. So select use all lights. You can see it just went black here. So what we want to do now is that we want to create a spotlight, and we have a very handy tool in Maya. You can activate it here or by pressing T, and what this tool will do is that you'll get two separate manipulators, one for moving your light and the second one for moving where you actually aim your light. So always use this when you're using a spotlight and you're trying to aim it. If you try and just rotate, you'll end up spending ages. So it can also be handy to use all four viewports to get a better idea of where you actually are in the 3D space. So if we go back to perspective now, I'm going to pull this up a bit here. So also what you're trying to do when you're setting up your light is that you're, in this case, you're trying to get a gradient going from full illumination to dark. So keep this in mind. Also, you can see we're not getting a very good approximation of what the light's actually looking like. So if we switch over to high quality render, you can see that it changed our viewport here. So also here for manipulator tool, we have a cycling index, we have a pivot manipulator. We can, if you look to the right here, you can see the cone angle is changing interactively. We can change the penumbra. We can change our decay regions here. So, but we'll talk about all this later. For now, we'll just stick to this one. It's by far the most useful. So if we go in here now, we can also turn on shadows for our lights in the viewport. But in this case, you'll need to turn shadows on for your light first, because by default lights will not display shadows. So just go down to shadows and check use depth map shadows, and you can see we now have a shadow appearing in our viewport here. So just to show you, I'll do a render, and if you look at this, you can see we're getting a very close approximation in our viewport of what it actually looks like in a render. So always stick with high quality render for the viewport when you're working with lights. So here we can redo the previous render. We can go in, select the region and just re-render the regions, which can be handy when we're working with complex scenes that take a long time to render because we have ray tracing and lots of things switched on. We can also switch over to IPR, which is the interactive photorealistic renderer, and when you do this, you'll be asked for a selection. So you'll just select the region you want to tune, and if I go in here and duplicate my spotlight, you can see that it's updating in this viewport. So you can see a lot of things in IPR. There's certain things that won't be supported in your viewport. We'll talk more about that later. But sometimes it's very handy to have the IPR, especially when you're tweaking materials. So you can see here how I've switched over to just use selected lights. So in our viewports, it will just display our selected light, whereas in our renders, both lights will be displayed. So keep this in mind. It can be good to isolate your lights sometimes when you want to see what one light is actually doing. So we can keep our images, or we can remove them if we want to. If you want to save an image, because when you close Maya down, your renders will get lost. So if you want to save a render permanently, you just go to Save Image, type in a name and save it. Another thing I want to talk about here is the render settings. So I'm going to open this one up. And you can see here we've got one tab with the common render settings, which is for all renderers. And the render we're using is Maya software. So there's also Maya hardware, Maya vector and Mental Ray. Mental Ray is a plugin. We won't be using Mental Ray in this tutorial. We'll stick with the very basic. So in the Maya software tab, we'll use this more later. We can turn on ray tracing here. We have some render options that we'll take a look at. But for now, I just want to show you that we have the edge anti-aliasing quality, which is quite important. So right now we're rendering at preview quality, which is what you want to use when you're test rendering your scene, because your renders will go a lot faster using this one. But when you have a final image and you're rendering out your final still shot or an animation, you want to switch over to production quality. And what this will do is that it will set our edge anti-aliasing up to highest quality. You can see there it's looking very jaggedy right now. So if we go in now and do a comparative render, you always want to do comparative renders when you're working with lighting. You need to train your eye to see. So you can see here preview quality with the jaggedy edges, and production quality, we get a very smooth finish. So that's pretty much it for this part. So different light types will differ in how they emit light and what attributes they have available to control them. So in this part here, we're going to speak about some of the common light attributes. So again, I've got a spotlight created in my scene. And we'll start by looking at different light types. I want to do a few renders, and then we'll speak about color and intensity. So the first thing I want to do now is that I want to do a render of the spotlight that we have. And I want to show you, because switching between different light types once you've created one is usually not such a good idea. So you can see here we have our spotlight with shadows. And if we go in now, and I'm going to save this render, we change this to ambient light. And we do a render of this. You can see there's very few controls for the ambient light compared to the spotlight. You can see it's a very bright overall illumination. There's no real sense of light direction in this scene here, and you can also see that we've lost our shadows here on the ground plane, and this is because ambient light does not support the shadow type we had set. So if we turn it back to a spotlight again, you can see here that the shadows are not coming back. So basically, when you switch between light types, the only attributes that will transfer over will be your color and your intensity. So once you have your light positioned, you don't really want to start switching it over to another type. It's better to decide from the beginning which light type you want to work with. So here you have the area light, and you can see now that the render became very, very dark. Area lights are very dependent on position. And now we're going to do a render of a directional light, and you can see we're receiving pretty good overall illumination again. If we go over to a point light, you can see it's fairly similar to the directional light at this point. We've got overall illumination, and finally we'll do a render of a volume light. And if you'll watch this now, you'll see it goes pitch black, and this is because volume lights depend on their light icon. So you need to scale this up. They only emit light within their icon. So here we have the different light types. You had the point, the directional light, which is good for distant light sources. We've got the area light, which depends on position. You need to place it very carefully. And we've got our spotlight, good multi-purpose light and easy to work with. And we have the ambient light here, which just gives a lot of diffuse overall illumination into our scene. But we'll speak more about the different light types in detail in the later parts of this tutorial. So if you look at color now, you've got a standard color wheel here, and the primary colors in computer graphics is red, green and blue, and if you add these in equal proportions they will produce white. So by default your light color will be set to be white. And if you look at these sliders here, with this one we can reduce the amount of red. So if we go and we slide this one all the way down to 0, we'll have no red, just green and blue illumination, and what this will produce is the color of cyan, and cyan is the secondary color located between blue and green. So you've got the primary colors, red, green and blue, and between them yellow, cyan, magenta, which is the secondary colors. And also you've got a whole grayscale range here. So when you want to pick colors from the color wheel, there's lots of theories about how to do this. You can pick complementary colors, which are on the opposite side of the wheel. You can pick split complementary, you can pick dyads and triads, and you can also pick colors. A lot of the time, if you want to create a moody setting, you can create colors that are very close to each other on the color wheel. So you can go in here and you can pick a red color, one that's slightly more towards orange and one that's more towards orangey yellow. And you can get a fairly nice color scheme going this way. So another way of picking colors, I'm just going to switch myself back to the spotlight here. Yeah, another way of picking colors would be through the pre-existing images. So you basically go in, look at an image. I have some image planes here that I'm going to bring up. I'm just going to turn on default lighting so we can actually see them. So if you pick your colors from an image, you'll have a lot of options. For example, you can go in and you can pick if you want some bounce light coming up from the ground, illuminating the undersides of your character. You could pick a green color. If you wanted some fill light from the sky, you could pick a blue color. If you had someone walking on the walkway here, you'd want to set the bounce light color to the same color as the walkway. So how you do this is just you go in and you select the eyedropper, and then you simply click. If I click here now for some green, you can see that's the color that the light will be set to. So this is a fairly good way of getting yourself started, getting a nice color scheme together. You can go in and pick your second. So this is why you can slide Maya aside and just click with the eyedropper, or you can import your images like I've done here. Depending on if you want to work with an image, maybe you'll want to pick many different colors from it. So and you can also see that Maya will store our most recent color selected, which is nice. So another way of picking colors would be through the temperature scale. So basically all materials will emit light if they're heated above 700 degrees Kelvin. So here you can see what some different materials would be expected to have as their light color. And this could be a fairly good way, same thing as before. You just go in with the eyedropper and pick your different colors. And this can be a great way if you want balance in your scene. For example, you've got some incandescent bulbs and you've got some blue skylight coming in, then you'll get the relationships between these different light sources correct. So this is how the temperature scale can be very, very handy when you're getting started. Like here you can pick some blue bounce light from the sky. So if you've ever seen a SimplyMaya tutorial, you know how to set up an image plane, but I'll just include it in this one as well, just in case. So what you do is simply you go and you create a polyplane. And you want to set your subdivisions down. This will rotate it in 90 so we can see it. scale it up a bit. We'll set our subdivisions down to 1. We don't need any subdivisions on our images. And then we'll go and we'll assign new material and create a Lambert. And now we're going to map a file node to the color here. So you just click this box and select the file icon. And then you just go and find your images wherever you might have them. I've got mine here. Got a lot of images. You can also, it can be handy sometimes, I've got a few more temperature scales here. You can see if you do a Google search you'll find lots of them, but this one has outdoor and indoor sources, which can be handy. So depending on what you're lighting up, you might want to use a different temperature scale. And this one here is for outdoor lighting. So here we've got some high dynamic range images. And what these are just images with a high range between the brightest and the darkest area in the image. So when you start to get used to lighting, you can use images and you can import them into Maya and you can try and mimic what you see. You can model up fairly rudimentary things and then you can see where shadows are falling. So you need to train your eye to work with lighting. You can see here you've got lots of blue fill light coming down. And the same thing here, full of blue fill light. So you want to look at images and try to think what your light color might actually be, because setting the right light color is very important for how your final image will actually look. Here you can see if you work with materials, you'll need reflectivity. So you need your materials to work in conjunction with your lights. Got images like this. I really like this image. You've got lots of different light colors coming here. You've got green and purple and blue. So all these things you can do with lights when you get a bit skillful. And again, this is a bit like the image I had up. It's nice. You've got a sky, you've got grass, you've got water, you've got lots of different sources where you can pick your light colors from. Here we've got a sunset image for one of those moody scenes. So I'm just going to import this one. So if we open this now, you can see I've created an image plane with an image. Just press 6 if you're not getting yours up. So this can be very useful if you want to work a lot off an image. If you might want to keep it in your viewport in the same way if people model, they keep reference images in their viewport. So you can do the same thing with lights. Just going to go back to use all lights here and move my bottles up a bit. And what I want to talk about now is I want to talk about light intensities. And selecting your intensity and your color is the most important thing when you're working with lights. So just going to set the color back to white here. So if you look at the intensity here, by default it's set to 1, and what intensity will do is it will tell us how bright an object will be illuminated. So if we start setting the intensity up a bit, you can see here at 1.5 it's getting a lot brighter. At 2 you're getting some bright hot spots. And if you set it up to 4, you can see that we've completely overexposed these bottles. We've washed out the color, because you want your intensity to work with your colors. So you can see here there's no color left, and also there's no gradient. So don't set your intensities up too high. You'd rather want to set up multiple lights in your scene with lower intensities. And another thing I want to show you is something, if you have symmetrical lighting, this can cause big problems in your scene. You never want to make your lighting 100% symmetrical, because when you do, we'll see in a second here. Just going to duplicate the spotlight over. And we're going to aim it at our bottles at the same angle. And there we are. And if you look at this now, you can see that we've completely flattened our objects. Because what you're trying to do when you're lighting in 3D is that you want to convey as much of the 3D shape over to a 2D image. And if you look at this here, you can see that we've got no gradient coming along our bottles. They're looking pretty much like when we looked at the image with ambient light. Ambient light can often flatten objects quite well. And you can see here, when we've got a nice intensity, that we've got a gradient going from complete black and then slowly along a grayscale. So you want to create grayscales along your rounded objects. And whereas you can see here, we've got no grayscale, we've just completely flattened our object. So this is why you want to be careful with setting up symmetrical lighting. You never want your lighting to be 100% symmetrical. And you can see now, even if we go and we set the intensities down a bit, because these intensities were very high, we've still got that flattened image. So you've basically taken all the shape you created in your model and you've lost it again. So in this part we'll speak a little bit about light linking and illuminates by default. And what illuminates by default will do in the current state is that you can use it as an on and off switch for your light. But actually it displays different modes of light linking. So when you have illuminates by default on, all objects in your scene will receive illumination. But if you turn it off, we can go in here to relationship editors and down to light linking, and we'll do a light-centric light linking. And what this will display is we'll have our light sources here, and if we select the spotlight, we can see that everything is blue here, which means that everything in our scene is receiving illumination from the spotlight. And if we turn off illuminates by default now, we can see it all goes black, meaning no objects are receiving illumination. So to light link them now, we go in and select them. So simply click the objects you want to light link to your light source. So if we light link the pink and beige bottle, when we render now, you can see that only the pink and the beige bottle are receiving illumination, and everything else in our scene has remained black. So if you want to display everything again, you can just go in and turn on illuminates by default, and you can see if you turn it off, you have two light links there. But as long as you keep it on, everything will receive illumination. And when we're using a light linked light, you can see here that if we go in and create a new object, it won't receive any illumination. It won't be visible in our renders, only the two bottles that are light linked will. So when illuminates by default is on, all objects will receive illumination that are created in the scene, whereas if it's light linked, your objects will need to be specifically linked to this light. So to break light links, you can just click the objects here, and if we render now, you can see it goes black. So we have no light links to the spotlight. So that's how light linking works. It can be very useful to work with if you've got more complex scenes and you've got multiple objects and multiple light sources, and you might want to link one to something specific, like light up a background, for example. So you can also set it to object centric, and what we will do then is just that you select the object that you want to link to your lights. So the spotlight's probably the most used light type in Maya, and the one you want to get control of first, because you can use it for pretty much anything. So if you look here, you can see that it emits its light in a cone shape, or from a cone-shaped icon. So if we render this, you can see we're getting a very sharp cone here, and currently by default it's set to be a 40-degree cone. So we can go in now and start increasing the cone angle, just so you'll see how it will change our spotlight. So if you wanted to emit light over a larger area, you might want to use a larger cone angle. You can set it up all the way up to, if you think about how the spot will work, you can set it up to 180 degrees. Something you don't really want to do, but if you look here, Maya will automatically set it to just under 180 degrees. But this can be, what will happen is it will distort your shadows and things like this. So you can also go and change your cone angle interactively. If you want to shrink it down, or you can set it up. So if you want to work with it in the viewport, that's one way of doing it, but it's probably easier to just type in values. So what the penumbra angle is, it's a value for how many degrees we want the transition from bright to dark to happen outside our cone angle. So if you look here, a value of 7 will mean that outside the cone angle of 40 degrees, there's a 7-degree transition happening from full light to full darkness. So another thing we can do in some cases with penumbra, you can see it's softened our light quite a lot. It looks a bit more lateral, depending on what you're trying to create with your spotlight, but you usually want to use some penumbra when you're using the spot. So we can also set it to be negative, which can be useful in some situations. And what this will mean is that that 7-degree transition will happen from the outer edge of the cone, and it will move inwards instead. So you can see here, positive penumbra of 7 degrees and negative penumbra of 7 degrees. So, and another thing we have to create some moodier settings would be the drop-off. So I'm going to set the penumbra back to 0, just so you can see exactly what drop-off does. And if we add a drop-off now of, say, 10 degrees, you can see this allows the transition to happen from the center of the cone, moving out, so you'll have full illumination at the very center, because penumbra only actually changed our edge. So if you want a more full overall darkening light, you need to use drop-off as well. And when you're using drop-off, you usually want to use it in combination with some penumbra. So if we render this now, you can see we've got a very soft, very moody scene. So this can be useful if you want to set up some very dark and very subtle lights. You can see we still have full illumination in the very center of the cone, whereas here we only had the transition happening at the very outer edge. So we'll save this and turn the drop-off up a little bit more. I just want to show you how you can make it very, very subtle. So there you have it. If you want just a small, barely visible light, you can do something like that. So you can try different values for penumbra and drop-off and see what works. You see here we have no penumbra. Here we have positive penumbra, transition happening from the outer edge of the cone. Negative penumbra, transition happening within the cone. We've got drop-off, transition happening from the center to the outer edge of the cone. And we've got some higher drop-off. So these are some things you can do to customize your spotlight a bit more to get the kind of lighting you want. So another thing you can do, if you want to further customize the way light's thrown, you can go in and turn on barn doors. And what these are is, on a normal spotlights, they'd be the metal flaps that you can fold down to shape it. if you don't want it to be round anymore. I'm just going to zero out our values to default, so you can see, and then we'll just tick them, and now we have barn doors activated. So these won't be visible in our real-time viewport, so you want to activate the IPR if you want to work with barn doors, so you can see what they're actually doing. And these can be great if you want to create some light slivers, like light falling out from a doorway, for example, late at night. And you can see we've got control over left barn door, right barn door, top and bottom. So you can just experiment with these until you get the kind of effects you want. And you can see it's looking very sharp now, so in the same way that we did without any barn doors, you might want to use some penumbra angle to soften the barn doors a bit. And you can see we're getting an overall softer appearance. One thing I want to mention here is that drop off. We'll set it up to something really high, like 50. When you're working with barn doors, your drop off won't work, so you'll only have the penumbra angle to actually soften the light with. So keep this in mind. So in this part, we're going to talk about cookies. We've got a spotlight here, casting light on the floor, and what I want to do is that I want to create some sort of illusion that it's casting light with something in it, so as a shadow falling from behind. So how we do this is we can map a cookie either to the color or the intensity. So I'm going to go with the intensity, and you can see it will bring up a 2D texture node and also a file node. So same thing as with image planes, you just go in and click on the image. I've got mine in source images. So I'm going to open up this tree silhouette image. And now you won't see it show up in your viewport, so you'll need to open a render view. And here you can see my cookies showing up. Just going to select the region here. We're going to make some adjustments to it, because as you can see, the light's supposed to be falling from outside the window and in, so the tree is obviously upside down. So this is easy to fix. Just go into the Place 2D texture node and just start to rotate frame, and you can see here that our tree silhouette is starting to move. So we'll just set this to 180. And now our tree silhouette is falling from the right direction. So if you get this problem, you just go into the 2D texture node. And you can also see here the intensity is now lowered down to 0.6. And this is because our texture that we've mapped to it is a black texture. So this will suck some of the intensity out of the light, since the color is not fully white anymore. So therefore we'll get a lower intensity. So maybe you want to set some penumbra on this as well. And if you look at what we'll have here, you'll see that this will have completely distorted our texture. It goes everywhere, and this is because the texture placement is based on the actual spotlight cone angle. So this is a case where you might want to set your penumbra to be negative instead. If you look here, you can see that it's going to follow the angle of the spotlight. So if you add the positive penumbra here, you'll just get it repeating itself in your penumbra angle. So therefore, if you try instead to just set it to -5 instead of +5, because you remember what I said about penumbra, the transition will happen within the cone now, and now you can see you're getting a softening edge here. But as it's happening within the cone and not outside, our texture does not start to repeat itself. Since this is a dark and moody scene, you might want to set some drop off on it too. And we'll render this. And you can see here, now we've got a sort of soft effect. I quite liked it without the drop off, but You can try different things. But this shows you how you can use a cookie to simulate shadows outside the window without actually having the geometry present there. You can see we can get a really, really soft one. So that's some different ways of adjusting your spotlight. If we go up now, if you want to get rid of your cookie, same thing as always, you just right click, hit break connection, and your spotlight will again have. So in this part I want to take a look at decay rates. You can set a decay rate for your light, and by default this will be set to no decay. So what is decay? Decay is something that will happen with lights, how they will naturally die out over distance. So if we render this now, you can see that this bottle in the front here will be receiving the same kind of illumination as these bottles here in the back. So in real life all lights will have decay. So this is something that we're going to have to work with. So you can set your decay rate to be linear, quadratic or cubic. Most of the time you want to work with linear. So you can see now if I set a linear decay rate for my light here, there will be no illumination. So as soon as you start to add decay, you will need to compensate by putting up your intensity. So if we set the intensity up to be 4, we can see we're getting some illumination now at the very front. You can set it up to 8. Now we're getting some more illumination coming through. And if we look at the render here now, you can see that we're getting a much more natural real-world lighting where the brightness is strongest at the very front of the light source and it's dying off gradually. So the second one down would be quadratic, and this is how lights will actually decay in real life. And again we can see it goes black, so we'll have to set our intensities up. 16 is not going to cut it. Go up to 32. You can see we're getting some illumination. So we'll set it up a bit more. So you'll have a more sudden drop-off if you're using quadratic decay than if you were using linear. We set it up to 128. You can see our bottles at the front are now very, very bright. And we're illuminating some of them a bit behind. But if you wanted more illumination, you'd have to set your intensities up even higher than this. So basically it gets more dramatic if you move from linear, which is quite a soft decay, over to quadratic, which is a lot harder. And if we now go down to cubic, you can see again we have almost no illumination even though we have an intensity of 128. So we can just start doubling our intensity rates at this point. So I'm going to set mine to 512. And you can see now we're just illuminating the very front bottles. So this can be useful if you want a light that dies off very, very suddenly. You want to work with cubic decay. But as I said, most of the time when we're using decay rates, linear would be the way to go. Here we have the quadratic, we have linear, and here we have no decay. So if we set this back to no decay again, you can see what this intensity is actually doing. It's very, very bright. So the higher you go with your decay rates, the more you'll have to set your intensities up. So working with linear is the best. So linear decay basically works as a compromise between no decay and the real-life quadratic decay that we actually have. The spotlight has a very unique feature where we can get even better control of our light intensity and how it decays over distance. And this is the intensity curves. So if you go in and just create an intensity curve, and then we'll bring the spotlight back up. You can see here, if we select our intensity curve, you'll get a table with, it says time here, but it's actually distance and different values. And you can also bring up your graph editor. And if you look here, you can see our intensity curve as it is right now. So by default, this one will have a lot of points. So you might want to go in and delete a few points if you want to work with it. So how the graph editor works is just like in the viewport, you zoom in with the mouse wheel, move around, and just select things. And to move these points, you just use the middle mouse button. And you can just pull them up and down. So what this will do is that it will override our intensity value and determine our intensities for us in the way we want to set them here. So I'm actually gonna go in and type mine in. I don't really like pulling points too much. So if we look at the table here for the intensity curve, you can see we've got point at 0 distance, and then we've got our different points in the first column where it says time, and then we've got the values. So as I move this one around, you can see I've now set it to a negative intensity of -54. But we're going to do a general curve for the decay. So we'll set it to 2, and then down to 1, and then 0.5, and then down to 0.2. And you can see in the graph editor how it will update. And then we're just going to zero this one out. So this will give us a curve that will simulate linear decay, basically. And you can see here, if we render, that we've got brighter illumination at the front, and then it slowly dies out. So your intensity curves can be used in many ways. You see, if I want it brighter here, at the very front, I just type in a value of 4. You can see that gave us a lot more brightness. I can increase this up to 8 if I want to. Now you can see it got very bright here. So depending on what you want, you can either use the graph editor to pull these points, or you can just open up your intensity curve in the attribute editor and just go in and type in different values. You see now, if I use this, I can simulate cubic decay quite easily by just forcing it to die off pretty much straight away. So I'm going to set our original values back, as I want a gradual decay of my light. And you can also use curve color. What this will do is just color your curve in the graph editor, and you can set it to be a different color than what it is if you want it more visible. You can make it yellow, for example. So as I said, we can use intensity curves to get perfect custom control of our decay rates, but you can also use it to create sudden hotspots within your illumination, which can be very useful when you're working with effects. You see, if we type in the value 8 here, we'll get a very light area in the back and darker areas in the front. So I'll just set this back, so I'm going to use it further. So if we go back to the spotlight shape node, as I said, your intensity is now determined by your intensity curve. So if we go in here and we type in a value of 10, you'll see that when we render, it will have absolutely no effect, because it's the intensity curve that overrides whatever we type in for a value at this point. So you can see it's exactly the same no matter what we type in here. So another thing that can be very useful is color curves, especially when you're working with creating things like explosions in dynamics. And so you create it in the same way. You just click create, and if we go in here, you can see in the graph editor that we've got a color red, color green, and a color blue curve. So as I said, light equal proportions of these three will give you white light. So if we go in here now, in the attribute editor as well, you can see we've got these three curves. So we can go in now and start adjusting them to get different colors appearing within our light cone here. So if you look now at the red one, we don't have any illumination really. So we're going to go, I want to illustrate something to you, so I've got some values I want to type in here. So we're going to set a very high intensity for red in the beginning here, and then for green we're going to set our intensities quite high around the center of the illumination, and we're halfway. And you can see how our curve's updating in the viewport. And then finally we're going to go up with the blue curve, and we're going to set some intensities there, and you can see what I'm doing here. So in the end we're going to have the low intensities for the blue curve, sorry, high intensities. So let's zero this one out at the start. So if we get it right now, you'll notice that where the illumination starts, we'll have only red light, which will then go into green, and then at the end it will turn into blue, because these will be the lights we'll be emitting. So a great way to get complete control of your light color and to vary it is through these curves. So again, same thing here. By default, a lot of points are created for our color curves, so you might want to delete your outermost points and just work with a few points. So if we render this now, should be able to see we're getting all the rainbow colors here. If you look, we've got red at the very beginning, green in the center, and blue in the back. And as I said before, these are the primary colors. So you can see where they overlap. I'm going to make this effect a little bit stronger. There's not really enough blue here, so this shows it much better. So you can see where we have overlapping, red and green are primary colors, and where they overlap we get yellow, the secondary color, and where blue and green overlaps we get cyan. So another thing we can do here is that we can just look at the color wheel, just so you can see this a bit better if you don't remember it. Red, green, we get yellow in between. And for green and blue, we get the magenta, and the purple is obviously not visible because we have nowhere where red and blue actually meets. So, but we could have adjusted this by setting red at the very end. So if we would have red light emitting through our curve, we could have had purple behind the blue again. So you can just set some penumbra for this to soften it up a bit. But you'd be able to go in here now and create some very nice images from these kind of curves. And as I said, in dynamics, they can be very, very useful when you want to create some kind of special effect with lights. So if we select the spotlight's shape node here in the graph editor, you can see, I'm going to zoom in a bit on it, but then you can see how these curves actually overlap. So you've got your white intensity curve, your red color curve, your green and your blue color curve. So by moving these points around in the graph editor, you can create pretty much any light color you want, as long as you keep the primary and secondary colors in mind. So another thing we can do we can go in and we can add some light fog to this. And you can see it's created a fog icon here. So I'm just going to change the viewport slightly so we can see the fog better. So if we render this now, you can see we got light fog, but it's only coming out this far. It's not stretching all the way. And this is because our fog is bound by our decay regions. So I'm going to open all 4 viewports. And I'm going to open up my Show Manipulator tool again. As I said to you, this can be very useful. And if we look at these are our different decay regions. So our fog will only stretch to the outermost region here, which is at 10 Maya units. You can also display decay regions down here. You've got 3 regions by default. They're not really that useful. Most of the time you'll only want to use 1 unless you want to cut off your lighting at certain points. So, but for now we can just stretch this one out, just pull it. And you can see in region 3 here at the bottom that our outermost decay region just got stretched out from 10 to 34. So if we render now, you can see that we have light fog coming all the way through. So the fog can be adjusted, you can increase the density. There's several attributes for fog as well. So you can bring up your light fog node, you can see it here. You can change the color of the fog, make it more dense, type in a value. You can turn off color-based transparency. You can get some pretty funny effects. So you can see how this can be very useful when you're working with dynamics and things that are lively and need a lot of color. So for now I'm going to try and show you decay regions, just so you know how they work. So we're just going to type in some different values here. And you should see, now we've moved this decay region from 8 to 22. So if we go in and... So you can basically, either you can type in your values or you can change them interactively with the Show Manipulator tool. So you can see now with the decay regions we've killed our lights in certain areas. So if you want to create these kind of light bands, this can be something you might want to look at, but I don't really use it a lot. So I'm just going to take mine. If you don't want to use decay regions, if you have them turned on like here, you can just cut them all down to 1. And now it will be back to what it was when we weren't using any decay regions. You'll see we'll have full illumination along the whole cone. So that's a little bit about how decay regions work. So we'll just go and turn them off. So for the light fog, if you want to get rid of it, you just right click, hit break connection. And if we do a render now, you can see that it's looking very strange. So in the case of light fog, you'll also need to go into your outliner. And you need to make sure that you don't have DAG objects only ticked. And you can see here, we can see our intensity and color curves. And we should have a node down here for light fog. So you have to go in here and just hit delete. And if we render now, you can see that there's no light fog. It's looking like it did before. So I think that's basically it. You can also go in with your intensity curves, of course, and color curves, and just break connection, and this will remove your curves. In Maya you have 2 types of shadows. You have depth map shadows and you have ray trace shadows. So in this part we will be speaking about depth map shadows. So depth map shadows are nice in the way that they're easy to use and they can be viewed in real time if you have your shadows turned on, and then you need to have shadows turned on for your viewport as well. And when you render depth map shadows, they'll render a lot faster than ray trace shadows, so when you can, you want to use depth map shadows. Spotlights are preferred as shadow casting lights because they'll have fairly good depth map shadows, and you can see here we're getting the jaggedy edges, and this is because we don't have our edge anti-aliasing quality up high enough. So I'm going to go into my render settings and go from preview quality up to production quality, because when we're looking at shadows now, we'll be looking at how the edges will be sharp and how they will blur. So we want to have production quality set. So shadow maps will work in the way that they will locate where the shadows fall by following the path of the light backwards from the lit object to the light source itself. And you can see here we're getting a much better result when we turn the edge anti-aliasing up a bit. So we're going to be speaking about the attributes now. The first thing we're going to speak about is resolution, which will set the pixel size for your shadow map. So resolution works in conjunction with filter size. So what you want to keep in mind as a rule, if you want very crisp shadows with hard edges, you want to work on high resolutions and low filter size. And if you want softer shadows, you want to turn your filter size up and keep your resolution low. So this is the general rule when it comes to depth map shadows. Their default values are a bit poor, so you'll usually need to tweak them. And as we're rendering in a map with vertical and horizontal pixels, you want to keep doubling your value. So at default we have a resolution of 512, so we're going to render with 1024. And you can see already we're getting sharper edges as opposed to here. So we can turn this up a bit more. You want to be a bit careful with turning your resolution up too high. Most of the time you're fine working at 512 or 1024. I just want to show you here how crisp we can actually get our shadows with depth map. But if you start turning your resolution up very high, you'll increase your render time, and it can be a bit self-defeating because you can get to the point where you'd actually get better results and faster render with ray tracing. So if you want really sharp edges, you want to use ray tracing instead of depth map shadows. So keep this in mind. But you can see here, the more we turn the resolution up, the sharper the edge of our shadow becomes. So if we go in now and take a look at the filter size instead, we can even turn this up, turn this down to 512, default value, and we'll take the filter size up a bit. I'm just going to render so we can do comparative renders. So here we are back at default. Our edges are not nearly as sharp as they were before. So depending on how detailed you want your shadows and how close up you are, you might need to use higher resolutions, but if you have them from a distance, you can usually work quite well with depth maps at a fairly low resolution. So just to show you, if we have no filter size, by default it's set to 1 because we need some filtering of these shadows. So you can see we're getting very jaggedy edges without any filter. So I'm going to go and set this up to 6 now. Usually working around 4, 5, 6 will give us fairly soft edges. So filter size work in the way that it just adds an edge blur evenly along the whole edge. And you can see now we're getting a lot of softening, but this will also increase our render time. We're up to 5 seconds as opposed to 3 here. So you want to keep this in mind. When you start to take your filter size up, you'll increase your render times quite a lot. If we'd set it to something ridiculous like 24, you can see that if we go and render now, it's going to take a fair bit of time. You can see now we're getting very, very soft shadows here. These shadows are very, very soft. You've got an edge blur going all the way along. They're a bit too soft for my liking. But this is something you can work a bit with. But as I said, you can keep your filter size around somewhere between 3 and 6 usually works fine. So also keep in mind that you can sometimes go in, if you cut your filter size down in half and your resolution down in half, you can get similar results. So again, depending on how detailed you want your shadow maps, because it's always render time versus detail, so if you want them to render faster, you can do that. So here it took us 34 seconds. So if we look here, it's fast if we cut our resolution down, because Maya doesn't have to calculate as many pixels. We can see we're getting the softer edges with some filtering, and here at 24, and here we have our resolution of 256, which might be a bit low in this case. You'd want to keep it at 512 or 1024. So, but depending on what you're looking for and how close up you're going to be, you can sometimes go and set your resolution down to get faster renders. So another attribute I want to look at, use mid-distance, and what this one will do is that it will be on by default, and you should leave it on at all times. It works to reduce shadow artifacts by it basically artificially pushes the surface's points closer to the light source. So if we do a render without mid-distance turned on, you can see straight away we're getting these artifacts appearing. We're getting these bands, which is the most common shadow artifact you'll see. On rounded surfaces you'll usually get black patches. So keep this in mind, leave mid-distance turned on when you're working with shadows. And mid-distance works in conjunction with the bias. Bias also works to reduce shadowing artifacts, so a small value will go a long way, so you want to be very careful if you start to adjust your bias. It can be a bit of a problem, because a lot of the time if you adjust the bias to get rid of one shadowing artifact, I'm just going to render here at default with mid-distance on so we can compare it if we set a few different values for the bias. But yeah, if you reduce your shadowing artifact in one place by adjusting the bias, you might have a new shadowing artifact appearing somewhere completely different. So, and you can see if you look under the bottle now, you can see that it's in this render when we've increased the bias, our shadow map is starting to move away slightly from our object. So this is a common problem if you have your bias value set wrong. You'll see that you can actually detach your shadows from your objects. So you'll see this a lot, so if you ever run into this problem, keep in mind that this will be a result of using the incorrect bias value. You can see here if we turn it up a bit more, it's moved even further. You can see it doesn't really look very natural, because we should have the shadow starting from beneath the bottle and going the whole way along, not at the very end edge. So I'll just turn it up a little bit more to show you how you can actually detach your whole surface from your shadow. So if you look now, you can see we have the object floating up in the air and the shadow is over there. So as I said, bias goes from 0.0001 to 1, and normally you don't want to turn it up too much. So another thing here is the autofocus. By default, Maya will use autofocus, which means that your focus that these depth maps will be calculated with will be set automatically, and most of the time this will work fine. But if you have a very large cone angle, you can see that if we turn this one up, this will usually lead to some problems with your shadows. Because if we go and render now, you'll see that there's not going to be enough pixels to actually calculate our shadow map when we have a very large cone angle set. You can see, because the light is now coming from a much larger light source, there is no shadow map occurring almost, because there's simply not enough pixels to calculate it. So to fix this, you can go in and you can manually set your autofocus to get your shadow map occurring here again. So if we go in here and turn off autofocus, and we'll set our focus to 45 instead. We'll render with this. You can see that our shadows are now appearing again, whereas here our shadows went missing completely. So when you're using a very large cone angle, you might want to set your focus manually, but if not, just keep it turned on at autofocus. So if you have any problems, if you see things like this, that your shadows are not occurring, you can try and go in and change your focus to see if this will fix your problem. Set my cone angle back to 40 here. So another thing we can look at here is shadow color. What you can do sometimes, because shadows are by default black, but if you want to give an impression of more fill light being present in your scene, or if you want to basically just soften your shadows slightly, you can turn your color into something slightly grey, just a little bit lighter, to give an impression of more light being present in the scene than what is actually there. You can see now our shadows are slightly softer, whereas here they're a lot sharper. I'll just do another render at black, and we actually have the same cone angle, so you can take a look at it. And now you can see how a lighter grey, it looks like we have more light coming into our scene, softening these shadows up a bit, so depending on what you have. You might want to tint shadow color. You can set your shadows to be completely different crazy colors too if you want to achieve some special effect. So, but most of the time you want to leave your shadows black or just tint them slightly grey. So if we look at this here now, first we have our depth map shadows at default. The kind of jaggedy edge, and here we have it when we turn our anti-aliasing up to highest quality. It's looking a lot better, but we still at default have some jaggedy edges, so to get crisp, sharp-edged shadows with depth maps, you want to keep high resolutions and low filter size. And if you want softer shadows with more edge blur, you want to turn up filter size and keep your resolution low. So we can see how the shadow got sharper. Here we have a filter size of 0. We can see the jaggedy edges. And same render, and here we have it set up to 6, and you can see we've got edge blur added. And also keep in mind that with depth map shadows, the edge blur will be added equally along the whole edge. So if you want edge blur that kind of blurs off with distance, you'll need to use ray tracing for this. So you can see we have the same kind of edge going along here. Same blurriness at the beginning of the shadow and at the end. And here we have 24 for filter size, way too high. And this is what happens when you turn the mid-distance off, so always keep it turned on to reduce shadowing artifacts. And then we looked at the bias. And remember this one, that you can detach your surface from your shadow if you keep your bias value incorrect. So again, when you use bias, a shadowing artifact that disappears in one place can create one in another. So with a large cone angle, you might want to set your focus manually and not use autofocus. But in most cases, it should work fine to turn autofocus on. So in here you can see with the manual focus set to 45, we got a shadow map. And finally we spoke about shadow color, how you could use it to give an impression of more fill light in your scene and softer shadow. So that's it for this part, and in the next part we're going to talk about ray traced shadows. So ray traced shadows should be used when you want very detailed, crisp edged shadows or soft diffused shadows with very high accuracy. It will massively increase your render times though when you start to use ray tracing. Also with certain light types, such as ambient light, does not support depth map shadows, so you'll have to use ray traced shadows. It can be a good idea when you're using directional lights, because their depth map shadows do not come out very well when you're working with transparency maps and when you want your shadows to blur over distance. So we'll take a look at all this now. So first, when you turn on your ray traced shadows, they'll be under your depth map shadows, so you just tick the box for use ray traced shadows. And if we go up here and render, you can see that we're not getting any shadows here. And this is because we need to turn ray tracing on in our render settings when we're working with ray traced shadows. So you just go into the Maya software tab, go to ray tracing quality, and turn on ray tracing. And if we render now, you can see we have shadows appear here. So you can see straight away that we have a very, very crisp edge on these ray trace shadows at default. Much crisper than with our depth map shadows, but in the case of the spotlight, and this is why, as I said, it's the preferred shadow casting light, your results will be fairly similar at default level between ray traced and depth map shadows. You can see here the edge is slightly more jaggedy, but it's not very far off. So this is my render from the previous video with the depth map shadows at default, and here's our ray traced shadows. So it's not really looking that different. So keep this in mind with the spotlight. It's very good to use with depth map shadows. And here you have some filtering applied with depth map shadows, as we saw in the previous part as well. So for spotlights, you usually want to use depth map shadows unless you have transparencies or something else, as you'll get faster render times and you will get fairly similar results. So, but one case is, as I just said, directional lights. It can be very good to use depth map shadows. I'm going to go in now and I'm going to save this. And we'll just slide it over a bit. And if we go in now and change our light type from spot into directional, just so you can see what I mean. We're going to render this image out. You can see these are our ray trace shadows at default. This one's obviously not aimed very well for directional lights. Our shadows looking a bit small and ridiculous, but you can see the edges is looking fine. It looks quite nice. And if we go in now and we switch this over to depth map shadows instead of ray trace shadows, you can see ray trace shadows are turned on and depth map shadows are turned on. And now we'll render with the directional light and you can see straight away we're getting lots of shadowing artifacts. We have big problems here because directional lights, they go in an infinite loop, so they kind of go on in eternity and they don't really work that well with depth maps. It's difficult for depth map shadows to calculate, so there you have them with ray tracing at default, and there you have them with depth maps at default. So directional lights, it's a very good idea to stick to ray trace shadows. And you can, of course, if you start turning up your resolutions, it will get better with your directional lights, but at this point, you might need to turn your resolutions up so high that you'd be better off just using ray tracing from the start. So we can try here maybe and turn the resolution up a bit to something like 248. You can see this is fixing the problem slightly, but as I said, if you have your resolution set up very high, you'll get high render times and you're better off just ray tracing from the beginning, because your results will be more accurate if you're doing ray traced shadows anyway. So spotlight is good for depth map shadows, directional light not so good. You should use ray tracing. So for now we'll switch it back to the spot. I just wanted to show you that. And we'll maybe set some penumbra here, soften it a bit. And now we'll go down and we're going to look at the different attributes for ray trace shadows. First of all, we have light radius. This is called shadow radius for ambient light, light angle for directional, and for spot point and volume it's light radius. So what this will do is that it will create a softer shadow if you increase the value. So ambient lights do not, area lights do not have this attribute, because the softness of their shadows is determined by the position and the rotation of the light icon. So all the other 5 light types have this attribute. So we have a default render here. And if we go in now and we set a value for the light radius, set it up to maximum is 1 for this value. And you're using spotlights. So we'll just render with that just to show you. And as I said, you can see how a softer shadow is occurring, but you can see that it's just looking very pixelated. It's not looking very good. So light radius works in conjunction with shadow rays. So when you start to use some light radius, you also need to increase the number of shadow rays. And the thing with shadow rays is that they take huge amounts of time to render, because for every shadow ray, Maya will have to go and calculate it and trace it back to the camera lens. So you want to be a bit careful when you're setting up shadow rays. I'm going to set 1 to 25 here. And you're going to see how much it's going to increase the render time. And if you have just one object, it's fine, but when you're calculating shadow rays and you have a shadow casting light calculating for 10 objects in your scene, this is going to take a long time. So all these attributes that increase our render times, we want to be very cautious with how we use them. But you can see now when we have more shadow rays in our scene that we're getting a much softer result. We're actually getting a blurred shadow here, not just a lot of pixel points as we did when we only had the light angle. And as you can see also, what I was saying is that you have this, when you used filtering with depth map shadows, it didn't blur over distance. But with ray tracing, you can see how the blurriness of the shadow actually increases. So this is one case where you want to use ray tracing if you want this kind of effect, where the shadow will change over distance and blurriness, because depth map shadows cannot calculate this. So we'll save this render. You can see the render time is 32 seconds for this blurry shadow here with the light radius at 1, so it's quite high, so I'm going to turn it down slightly to something like 0.3 and turn my shadow rays down as well, because if I have a lower light radius I won't need as many shadow rays, so I should be able to render with about 15. So we'll render this out too. And you can see here our shadow is not as soft as it was before, but it's got a bit of softness, and you can see it's still blurring over distance. So depending on what you want to do, this might be good enough. You might want to add a few more shadow rays to this. You can see here we have a very nice blurred shadow, but it's going to take 32 seconds to render this one image out. Whereas in the next one, we've cut our render time in half. We're down to 16 seconds, and we're still getting a fairly good shadow. So, and when we were rendering this with filtering, with depth map shadows, remember our render times were around 3-4 seconds there. So this will be the difference if you're using ray trace shadows versus depth map shadows. So be a bit careful here and keep your shadow rays as low as possible. So ray depth limit is an attribute that will matter when you're working with reflections and refractions. It doesn't really matter that much to us here. Basically, higher values here will allow ray traced shadows to appear within a greater number of repeating reflections or refractions. So we could, if we set this value up, it wouldn't make any difference. Obviously, if we set it down to 0, our shadows will go missing because they're not appearing and they're not reflected back to the camera at all. So you need to leave it at its default 1 to be able to actually see your shadows. But if you turn it up now, as we don't have multiple objects or not ray tracing anything else here, it won't make any difference in our scene how high we'd set it. So as you can see, our shadow is looking the same. So that's pretty much the important attributes for how to tweak your ray trace shadow. Increase your light radius if you want softer shadows. And if you do this, you need to compensate by turning on shadow rays and increasing the number. And when you do, you will increase your render times. So depending on how soft and blurred you want your shadows, the higher your light radius would need to be, and the higher the amount of shadow rays. So if we look at this material here, another case when you want to use ray tracing is when you're working with objects that are transparent, because this is something that depth map shadows will not take into consideration. They will just calculate your geometry all the same, whereas ray tracing will actually take your material properties into the calculation here. So if we just go in, I have my Lambert here, so we're going to turn up the transparency, and you can see now in the viewport that we have a transparent object. I might set my intensity up a bit so you can see this a bit better. And if we go in now and we render this, can see here in our shadows that they're getting a lot lighter in the center, which means that our transparency is being calculated. And you can see here at the bottom too. So if you had a transparent object in real life, you'd have much lighter, much softer shadows, as you do here. So another thing you should just think about is that you can't view ray traced shadows in the IPR, or in the viewport for that matter, if you do any changes. So you'll need to render everything. So this is why if you're doing test renders and things like this, you might want to turn your light angle down, or your light radius and your shadow rays, because it might save you a bit of time. This is also a case when you might just want to render a region instead of render out the whole frame, because you can see we're starting to spend time on our renders now. So now I'm going to render this with depth map shadows, and you can see the difference here. It's all just pitch black, whereas here we have the transparency calculated and we're getting this soft shadows giving us a slight illusion of glass. So this is something, so every time you're working with transparent objects, you should think about this. If you have something like window glass as well, you'll need to use ray trace shadows, because if you're sending light through a window with transparent glass, the whole room will be pitch black if you're using depth map shadows. So, and you can see it doesn't look very realistic either to have these types of shadows for objects either. So if we go back and just have a look through this, you can see here we had our default ones. This is our spotlight with a bit of filtering along the edge, and here was the spotlight at default, and here's our ray trace shadow. You can see straight away, even at default, we have a much crisper edge here, but our render times start to go up. Directional lights, this was one of the cases where you want to use ray tracing. Here you had them with depth map shadows, lots of artifacts, and as I said, you can compensate this by turning up the resolution, but when you do, you might have render times that are a lot higher anyway, so you might as well just stick to ray tracing for directional lights. So back to the default render of ray tracing here. And here we increased our light radius. And you saw we got all these pixels here. So to compensate for this, you need to go in and turn up shadow rays. And you can see the render time went up to 32 seconds when we did this. So you need to use sensible values for light radius and for shadow rays. You can see if we want a very soft blurred shadow though, we need to go with ray tracing with high values for the light radius and the shadow rays. And here we have also ray tracing when we're working with transparencies, because they will calculate this, that we have a transparent material on our object and our shadows will display this, whereas depth map shadows will just calculate the geometry. So that's all for ray trace shadows, and I'll see you in the next part. So before we spoke about light linking, and in the same way we can link our lights in Maya, we can also link our shadows. It works in a slightly different way though, and this can be useful if you're working again on more complex scenes and you might have shadows being cast on an object that you don't really want, and then you can go in, for example this one here, you can go in and you can get rid of these shadows. So to do this you have to start by going into your render settings, because by default our shadows will follow our light links. So if you look in the Maya software tab here under render options, you'll find a header saying lights and shadows, and under here you have shadow linking. So if you go in now and change this to shadows obey shadow linking, you can start setting up shadow links. So I've got a spotlight in this scene. So what you do is that first you select your light and then you select your object. You can see if I zoom out, there's my spotlight. And when you've got your light and your object selected, you go up to lighting shading. And now we can go in and we can break these shadow links. And it won't show up in our viewport. But if we open our render view, you can see the shadows here. And we render this again, you can see the shadows disappeared now because we've broken the shadow link. So with shadow and without shadow. You can do the same thing for all your different objects, whatever shadow you would want to get rid of. Also, if you want to restore your shadow link, in this case, you can go in, select your object, Then select your light. And then we go back into lighting shading, and instead we go make shadow links. And if we render this now, you'll see that our shadow will appear again. So if you'd break a shadow link and change your mind, you can always just go in and restore it. It's very simple to do. So now we'll select this object. If we want to get some additional controls, we can look in our render stats for our objects. So for this object, for example, we can go in and we can turn off cast shadows. We can turn off receive shadows here, and you'll see no shadow will appear on the object. You can turn off the object's primary visibility. So if we render this now, this object won't be visible. We can turn on whether it's visible in reflections or in refractions. We can do the same thing for any object in the scene. Just go into its render stats and turn off receive shadows. And as you can see, these things will update in our viewport as well. You can select this one, turn off its shadow casting. So if we save this one and we render it out now, you can see that we've got objects in missing because there's no primary visibility. Here we've turned off cast shadows, and for this one here we've turned off receive shadows. So this gives us a high level of custom control over our shadows. So in this part we'll speak about some of the most common Maya shaders and how they differ. As this is a lighting tutorial, I don't want to spend too much time on it, but lighting and shading should be done together, so when you're working with lights it's important to know how different materials work as well. So if we look at emit specular and emit diffuse, it will determine whether a light will affect the diffuse or specular calculations of a material. So basically if you'll have specular highlights or not. And the ability to emit diffuse or emit specular is a property of all Maya light types except ambient. So when we're working with materials here, you want to open the hypershade. I'm just going to show it to you quickly. It's under rendering editors, and on your left hand side here you've got all your different Maya nodes, and the most common shaders here that I've created is anisotropic, Blinn, Lambert, Phong and Phong-E. So if we go back here, I'm going to open an IPR. Very handy when you're tweaking materials. And we'll just select this region here. And first of all, I want to talk about emit diffuse. So what you can do is you can set a light to emit diffuse only. And as you can see here, all our materials will look exactly the same. We have the default Lambert, and then we have the Blinn, the Phong, Phong-E and the anisotropic, and they're all looking exactly the same. So materials differ on how they emit their specular highlights. And the ability to emit diffuse only, to use a light like this, could be good if you have secondary lights. So if your light is a secondary light source, like a bounce light, for example, light bouncing up from the grass, it could be good to have it to emit diffuse only, so you don't get specular highlights occurring in places you don't really want them. So for emit specular, we'll turn this back on. So now you can see our materials display very differently. So you can see our Lamberts disappeared because it doesn't display any specular highlight. They differ a bit here. You've got the Blinns very soft, and so is the Phong-E, and then between them you have the Phong, which is a very sharp specular highlight, and you've got the anisotropic material at the end here. So a problem you have if you want a light to emit specular only, when you want to boost specular highlights in something, because if you would want your specular highlights to be a lot sharper on an object, and you started putting your intensities up, and you had it set to emit diffuse as well, you can see that you'd quickly just overexpose your whole scene. So therefore it can be very handy if we set a light to emit specular only. And you can see here, as a spec light, we can just keep yanking the intensity up as high as we want it. And this can be good when you want to boost specular highlights somewhere on a character, or there's many different places. And spec lights, a lot of the time you'll need to link them, since they're very specific purpose lights. So, but for now we'll leave emit diffuse and emit specular on. And we're going to go and look at the Lambert first. So the Lambert's a very matte kind of surface. You can see, as I said before, if we turn emit specular on and off, it won't make any difference to the Lambert, as it doesn't display any specular highlights. So this material can be very good to use for things like matte surfaces, if you have clothes, unglazed ceramics, mud, anything basically without specular highlights. So if you look up here at the type, you can do the same thing as you could with lights. You can go and switch to any other material type at any point you want to. So these are the common material attributes, so all materials will have these attributes. So I'm going to go through them quickly now. First we have color. It's fairly self-explanatory. You can just go in and select a color. So the second attribute we have is transparency, and this will determine how see-through an object is. I don't know how well it will display here. But if we keep turning it up, you can see the more we turn it up, the more see-through an object will become. So at white we'll have it completely transparent, and at black we'll have no transparency at all. So you can also see up here your material sample. As you tweak your attributes, your sample will update. So this can always be handy to have an idea of what you're actually doing to your material. So now we have ambient color. And what ambient color does is that it lightens the color of a material. If you increase it, it adds a bit of color to mix in with your original surface. So you can see it becomes a bit self-illuminating. You want to be careful with using ambient color, but it can be good to use in a scene. If you have vegetation, for example, you can set your ambient color up to a little bit of green, and this can help to bring things to life. So, but by default it's set to no ambient color, and also if you have ambient light in your scene, your ambient color will be stronger. So, and just gonna pull this one. It happens sometimes that the IPR gets a bit stuck. And then we have the incandescence, and the incandescence will cause an illusion of the surface emitting light. So basically it brightens in a similar way to ambient, but the difference is that the incandescence, it will override the color you have set on your shader. And also it doesn't rely on any lights being in your scene. It will just self-illuminate, different from ambient color when you actually need to have light in the scene for it to work. So it kind of reminds me of a light bulb. So the next attribute is bump mapping, and bump is used to imply that a surface has more detail than it actually does. It will work by offsetting surface normals, so you can go in here and you can map something to it. We'll just choose a fractal for now. You can map lots of different things depending on what kind of result you want. But you can see here now we're getting an illusion that there's a lot of grooves and crevices in here on our surface. So it's a nice quick way of So if you want to get rid of your bump, you can just go in and right click and go break connection, and you can see that got rid of our bump here. So diffuse, well, this is the same as the diffuse overall lighting. It refers to how light is spread widely. So if you turn it up to a high value, you will get a very bright surface, and a low value will cause more light rays to be absorbed, and it will darken your surface. You see, as always with the sliders, we can always type in values. if we want to increase the slider. So you can see there it goes completely black if we turn the diffuse off. So translucence, it will determine how light travels through a medium. So basically it means to make the other side of your surface light up too. And this is an attribute you want to consider when you have translucent materials. For example, if you're trying to create paper, leaves from the tree, candle wax. So you can see it's not really displaying that well, but you can see when you're using translucence, the front of your surface will light up as well as the back. So, and if we go and speak about translucence depth, it will simply determine how deep into a volume light will penetrate. So we won't really see any changes here if we change it around, because this is not really a good image to view translucence. So, and translucence focus at last will determine the direction scattered light will take as it passes through a surface, and if you increase it, it will cause less light to scatter back at the camera. So depending on what you're creating, if you're creating an object like a balloon, you want to have a very high focus. So now we're going to go and look at Blinn. And Blinn is a good material if you want to create softer metals. It's got a lot softer specular highlights than the Phong to the right of it. And you can see here now we have an additional menu for specular shading. So this will be available for all other materials than Lambert. So for controls here, we've got the eccentricity. And what this will do is that it will control our specular size. So if we increase it, we'll get larger specular highlights. If we decrease it, we'll get smaller specular highlights. So you can see now we've just widened out the whole object. And if you take it down, it starts to look more similar to the Phong next to it. So basically by tweaking these attributes, you can make shaders look pretty similar in their specular highlights. So the specular roll-off will control the specular intensity. So as you can see on the lights, we can just control how much, whether we have specular or not, but here we can control the appearance of the specular highlights. So you can see there, if we turn the intensity down on the specular highlight, we'll make it look pretty much like a Lambert, because at 0 there will be no specular highlight. So then we have specular color. It's also quite self-explanatory. You can set any color for your specular highlight should you want it to have a color. For example, there we have a green. This looks quite terrible, but you can do some funny things with specular color. We'll set it back to grey. And finally we have reflectivity, and this will determine whether your surface will reflect its environment. So it's quite important. You can use it when you're working with glass and things like this. You might want to use reflectivity. So if we go now and we take a look at the Phong instead, you can see that Blinn, Phong and Phong-E, the three in the middle here, they have fairly similar specular highlights. So the one on Phong is very sharp. Phong can be used for things like plastic, porcelain, glazed ceramics. But you've got fairly poor control. You can see here you've only got the cosine power, whereas on the Blinn you had eccentricity and specular roll-off. So what this one will do is that it will control the size of your specular highlights. And so controlling a Phong can be quite difficult, so it can be better to work with Blinn or Phong-E for that matter. You can see we can shrink it and we can increase it. And as before, we can set a specular color. So default it's at 20. So that's pretty much it for the Phong. If we look at the Phong-E instead, it's got a lot softer specular highlights. It renders faster, faster as well than Phong, and you've got a lot better control here because you'll have two controls for your specular highlights. If you look down here, you have roughness and you have highlight size. So a low value of roughness will cause the highlight to fade very quickly, whereas a high value will cause it to fall off in a more similar way to blin. So we can change it. You can see there, the high value, it's very diffused and very sharp if we set it down. So at default it's at 0.5. So the highlight size obviously will control the size of our actual highlight. Just slide it around so you can see the differences here. You can see we can get a very small, tight specular highlight with a very low value. So, as I said before, the three in the middle, blin, Phong, and Phong-E, they only differ in ways of controlling them. So, working with blin and Phong-E is a lot easier than working with Phong. So, you also have the attribute for whiteness on Phong-E, and it allows another color to be blended into the highlight between the colors set by color and specular highlights. So you can see if we put a blue on there, and then put a green color for the specular color. Don't know if you can't really see it that well, but it gives you extra control over how your highlight color will actually appear, so this can be quite a handy attribute. With Phong, the specular color will tint both reflections and highlights, and the whiteness offers two controls for this, where the whiteness will tint the specular highlights, but it won't tint the reflections. But now we'll go in and we'll take a look at the anisotropic material. And it's good for materials that aren't directly uniform. And it will also, these specular highlights will rotate with the view, so this can be good to use with things like feathers, brushed metal like aluminium, CDs, of course, Christmas balls. So you can see here, that looks a bit more like a satin Christmas ball. So you can always just rotate the angle depending on what kind of result you're trying to achieve. You'd want it at 180 as well if you were doing, say, a brushed metal bowl or something like this. So the spread for X and Y, it will determine how wide the grooves will be in the respective directions. So you can see this tightens it up a lot. So again, basically how soft your specular highlights will appear. See here, we can completely kill the anisotropic feature of the shader and turn it into something more like a Phong. So roughness, same as before, we'll control a higher value will give a larger and more diffused highlight, and a lower value will give a sharper highlight. You can see it better now. So, and finally we have the Fresnel index, which controls the intensity of the specular highlights. Take it up a bit to 12. You can see it got a lot brighter. Take it up some more. And if we go back, again, all these controls allow us to basically kill our specular highlights. So any shader can be turned into a Lambert simply by either preventing the light from emit specular or from turning your specular shading attributes down to 0. So first of all, we have the Lambert, the default shader in Maya, good for matte surfaces, like I said. And then you have the Phong-E the Phong and the Blin. They're quite similar. They differ in methods of control. Easier to work with Phong or Blin than to work with Phong because you only had the cosine power to control the size of the specular highlight. So and finally we have the anisotropic one. And remember that you can rotate these specular highlights with the angle, which is very useful because it allows you to create a lot of different materials. So in this part we'll speak about how to illuminate your characters using 3-point lighting, which is a classic Hollywood scheme when you've got them fully rigged and textured like this. So the first thing you want to do is create a camera, which you can do either through the shelf or you can go into cameras and create camera. And you'll get a manipulator up, just like when you're aiming lights, you can use this to aim your camera. But a much better way of doing this would be to go into your perspective view and set your perspective view to be your camera view. And in this way you can just pan around and zoom until you get a good view that you're happy with. So 3-point lighting is shot specific, not scene specific. So I've already got a camera here that I'm going to open. So this is why you need to render through a camera. So if we go in now, you want to make sure you start in darkness. So turn off default illumination and you can see it goes all dark here. So this is your starting point. And if we go in and look at all our viewports here, I'm going to show you how you set your lights up properly. So I've already created my lights. So the first light you want to create is your key light. And if you look at the viewports here, you can see that I've aimed it. So it's slightly offset. There's my camera. And here you have my light. And also if you look in the front view here, you can see that you want your light to be set at about 45-degree angle higher than your camera. So I'm going to turn my light on. So your key light is your main illumination for your subject. And it should be your shadow casting light as well. So this is the light that will set your light direction. And when you have this light in your scene, it should look fairly close to what it will do in the very end when you've added your other lights. So you want to stop and test render here. And you can see now you need to set your render view to render through your camera. So if you go to render here, and we'll just set it to my camera. And now you can see I've got fairly good illumination. You want to leave some areas in darkness, and I've got the shadows here falling from my object. So you need to aim your key light right so you get your shadows falling in the right place. And the second light you want to create is a fill light. And what a fill light does is that it will soften the illumination provided by your key light. So you can see here you want to offset this one to the other side of your camera, and also you want it to be a lot lower than your key light. So you can set it to about the same height as your subject, but it needs to be lower. So your intensity for your fill light should be about half the intensity of your key light. And you should not use any shadows on this light, because we only want shadows from the key lights. And if you're working with darker areas, you can set your intensities even lower if you want very shadowy areas for your fill light. So, but half, and then take it down from there. So you can see now we've got a lot softer shadows. And you can see areas that were before in darkness are receiving a lot more illumination now. So the final light we're going to talk about now is the rim light, and we do this to make our subject pop out from the background. So you want to add a rim light at the very, very back, opposite your camera. If you look at mine here, you can see I've got my camera here, and on the opposite side I've got my rim light. And usually you'll need to set it up quite high. So aiming rim lights can be quite difficult. And you can set your intensity of your rim light as high as you want it. I'm going to set mine to 0.5 here, but you can keep it at 1 or take it up even higher if you want to, because all you're trying to do is boost this glistering sense in the back of your object. So you can see now I'm getting a bright illumination here, a few pixels. It should be like a halo effect when you're talking about rim lights. Otherwise it's a backlight, a form of kick light. So I'm having a problem though. You can see here that my light's going through my material and it's appearing where I don't really want any bright specular areas. So for this reason, you'll need your rim light to cast shadows most of the time. And if you look here now, you can see I have a problem because these shadows are appearing everywhere. So I only want the shadows from my key light. So what I can do now is that I can go in and I can light link my rim light to illuminate the T-Rex only. So I'll link it away from the floor plane. So you can see now when illuminates by default is on, everything's illuminated. And if I turn it off, I can just click here to link it to the T-Rex only. If we go in and render now, you can see our shadows have disappeared. And we've got only the shadows from the key light. And we've got a nice halo effect here. Sometimes you might want to use multiple rim lights, so you'll need to set up several lights in the back and aim them. And in the same way you're using one fill light, you can use several fill lights too and put them a few degrees off close to each other. So this depends on what you're trying to achieve, but you don't necessarily want just one light in one position. So here you can see this is my spec light. So you can use these lights. I've got it exactly in the same position as my key light. And if you look now, I'm going to use this one only to boost specular highlights in my object. So I'll set it to emit specular only. And therefore you can do this because you couldn't turn your intensities for your key lights up a lot higher, but if you wanted to get a glistering sense, you could use separate spec lights in the same position as your key lights as well. So you can see the difference here. I think I preferred mine without the specular light here. But that's some ways you can get fairly good illumination. You can see with just the key light. And now we've managed to soften the shadows a bit with our fill light. And finally we've added a rim light here. And here is the spec light should you want it. So that's how you can light your characters up in a fast and simple way. So in this part I want to speak about point light and ambient light. And first of all we have ambient light here at default levels. We're going to do a render. And as you can see it's kind of difficult to tell a light direction with ambient light. It gives a very soft overall illumination into your scene. You can pull it up here, you can see the light icon. So ambient light will give off soft light in all different directions. The light icon itself can't be scaled, and an ambient light can be used for soft fill light and light that bounces off walls and the ground, but it's very, very difficult to control ambient light. The only control we actually have here is the ambient shade. So what this attribute will do is that it will control the balance between omnidirectional and directional light rays that are emitted. You can see if we turn it down to 0, the light is red with equal intensity at all points in the scene. So at this point it doesn't matter where the light icon is placed, but it will completely flatten out everything. And if we turn it up to the default level, which is 4.5 or 0.45, sorry, we'll have a mix between the omnidirectional and directional rays. You'll get some more character, some more sense of depth. And if we turn it up to 1, which is max, you can see we're getting some more light direction and some more character added here, some more three-dimensional shapes. And at the point when ambient shade is 1, the ambient light is pretty identical to a point light. So, but ambient light is very difficult to use, so because of this being the only control you actually have. So ambient lights is also the only light type that doesn't support depth map shadows. You'll have to use ray tracing. So you have to go down and activate ray tracing if you want shadows. And as we can see, the shadows are coming in all different directions. So ambient light is something you don't really want to use too much. It's basically the same type of overall illumination. It will lighten everything in your scene and you can't really control it. So we'll switch over to a point light. You can see the difference now. One thing that ambient light does not do is that it doesn't display specular highlights on material because it doesn't have the ability to emit specular. And also, you can see here I've got a Phong. In addition to this, I've got a fractal map to it, so I've got a bump on it. And this is another thing with ambient light, it will not display bump. So if we render this with a point light now, you can see we can see the fractal that we've mapped here, and we can also see the specular highlights. So this is a great difference to ambient light. So we've got some more controls for our point light. A point light will emit light in 360-degree angle. It will basically be omnidirectional light going in all different directions. And if we move it around here, you get a much better sense of light direction. So point lights are of course useful for light sources such as light bulbs that are just emitting in all different directions, and they can be good for setting into your scenes if you want to test render a scene and see what's actually in there. I usually stick in a point light just to brighten the whole thing up a little bit. So you can control the emit diffuse and emit specular, which is different from ambient. So you can set it as a spec light should you want to. Or to just emit diffuse. So we can also set decay for a point light. And we've got light fog and light glow for light effects. And the point light will support depth map shadows. So if we render with this, you can see we're getting some fairly good depth map shadows, and with shadows activated you can get a better sense of the light direction as well. Turn off depth map shadows. We can have a look at the ray trace shadows for point lights as well. You can see they're fairly similar at default. So with point lights you can use depth map shadows. You can emit specular or emit diffuse. You will be able to display the bump. Different from with ambient here, where you can see that there is something on there, but it's not displaying the bump properly. So there you have ambient light with ambient shade set to 1, where it's fairly identical to point light. In this part we'll speak about volume light and go through the different attributes available for the volume light. So we'll start by creating a volume light. You can see I've got a number of spheres in this scene, and if we render this, it will remain pitch black, and this is because volume light only emits light within its light shape. So we're going to need to scale this up. can see the larger you scale it, the more illumination your surrounding objects will actually receive. Volume lights give off a very soft type of illumination, so they can be great for simulating things like candlelight effects. You can see now all our spheres are receiving some illumination. So this light depends on position as well. So if we move it up a bit like this, you can see that illumination is coming from the center and slightly above. So we'll get a much better overall illumination. So you need to think about where you place your volume lights, in addition to how you scale them up. If you look at it here, I've got a blend material with some specular highlights, so we'll be able to see this a bit better, because the volume light gives off a very, very soft illumination. So I'm gonna turn the intensity up a little bit too, to make it a bit more visible. And you've got the same attributes here as for most of our light types. You've got emit diffuse and emit specular. You can also go in and change the light shape icon to a box, a cylinder, or a cone. So you've got great control with the volume light over where you'll actually be emitting your light. So we'll stay with the sphere for this. So basically all illumination will come from the center, and it will not leave the outer edge of our light shape. So here we've got a color range, and what this one does is that it goes from full brightness to complete darkness here. So the outer edge, it's set to black. So if we change this to white now, you can see that we're getting a much brighter result as opposed to here. I might just scale this up a little bit, so now all our spheres will be receiving full illumination from the volume light. So if you look at this color range, it's quite funny to play with. If you just click within it, you can create more colors, and then you just go in and click here to select different colors. So in my case now, I'd like to work with something that's a bit warmer. So just click to select, and then select the color you want. As I said, it's good for candlelight, so we'll pick some warm colors here to put into the color range. And also, if you render this now, you can see it's going from white out to cream color, out to yellow, out to red. So we might want to go in here and add some more red with the slider. So you just slide these little icons along, just click them with your right mouse button and just slide them to change how the colors interpolate. And now you can see we're getting a lot more red in our render here. So should you want to get rid of one of these icons, you just click the little X at the bottom, because it's quite easy to click and get too many colors in. Now you can see it's getting redder and redder. I might want to add some more white at the center here. You can also choose how you have interpolation set. It can be non-linear, smooth or spline. So you can see if I choose this one here and we set interpolation to none, you can see that there's no transition between them. It's just a very sharp. You can see now it went a lot rougher. So we've just got a direct cutoff between red and yellow, whereas here we're getting all the colors in between, some orange. And so I'm just going to keep mine set to linear for now. So here you have the volume light direction. Your volume light can be set by default. It's set to emit light from the center of your light shape and then going out. So you can also set it to emit light inward. You can see now we're getting these arrows here. So basically how the light will go now is that it will go from the outer edges and in towards the center. We render this. You can see here, you can see a clear light direction, how it's coming from the outer edges and moving inwards instead. So this is quite funny. You can create a lot of effects using volume lights. You can scale them up really large. They can be useful to light up whole rooms with as well. So we also have the down axis. And if you look here, you can see it's created an arrow. So now all the illumination will come from the top of our sphere and just move down. You can see all objects are receiving full illumination from the top. So these are the three different ways the volume light will set its lighting direction within the light shape. You also have an arc here, so by default it will emit along the whole sphere, but if you set it to 90, you can see that only a 90-degree slice will receive illumination. So I'll set mine back to 360. You can also set a volume light to emit ambient light. It can sometimes be more useful than using an actual ambient light because of the lack of controls. So you can see straight away that ambient light is present. I'm going to set this back to default outward. And under light effects we can create light fog. And if we render with this, you can see you can get a really nice candle effect using light fog and a volume light. Your red would obviously be at the very center and then move out to lighter colors, but you can get some really nice effects using volume lights. Also you have light glow, and for shadow types the volume light will support depth map shadows and ray trace shadows. I'm just going to soften my intensity a bit here. And you can see the kind of soft illumination we get with the volume light at lower intensities. In this part we'll speak about area lights. Area lights are physically based lights that will emit from a flat area. If we look here on wireframe, you can see that I've got an area light placed in my window. So they're nice because you can scale them to the correct size, so they're good to use when you want to place a light and have good control over exactly where it will illuminate from. So as you can see here, even in the preview, you've got a sort of natural decay with area lights. Do a quick render. You can see that they will decay over distance. You've still got decay rate, so you can set decay if you want to speed it up a bit. So you have a few controls. You can set them to emit specular only, or you can set them to emit diffuse. In this case it works a lot better. You can create very moody scenes with area lights. So you can change the light color. I just have a few colors I want to show you here, just so you can see how we can get very different moody settings using area lights. So they're good for light filtering through a window, or if you have light bouncing off a large wall. So how they work is that you have them, basically you have numerous point lights scattered along your flat shape, and then they will emit in all directions coming from there, so it's not just light going straight forwards. You can control the intensity, of course. I turned mine up a little bit. For light effects you've got light glow, and area lights will support depth map shadows and ray trace shadows. So they can be very good lights to use. I've got another example here. If you remember when we did the light animation, I had an area light in the back to create a sort of feeling of some soft illumination coming off from a backlit sign. So area lights are good to use for things like this as well. You can use them for signs, strips of neon light, monitors. They can recreate fluorescent light fixtures. So you can see here we're getting a very soft, moody illumination, as if we would have a doorway where you'd have light coming out, or maybe an emergency exit sign. So we can duplicate a few area lights here. Just so you can see them a bit better. And we'll render this. Now you can see what we can do with them. For example, if we had several signs, it would be nice to light them up with a few different area lights in the back. I'm just going to delete my center one. And you can see here very well as well how they decay, and also how there's no illumination coming from behind. So they're very dependent on position. You've got a light icon at the front here. You can see the little pointer there, and this one will determine the direction that your area light will take. It's quite easy to see anyway. As soon as you create an area light, you'll see what they do. So they can be rotated, and you can see here very well now where the illumination is actually happening. You can scale them, and you want to keep in mind that area lights, when you scale them up, different from other light types, their intensity will actually increase. So if you scale your area light up to a very large size, you'll usually need to compensate by lowering your intensities. If we look at this render now, you can see it's very, very bright. So if you wanted to simulate a large backlit sign here, you'd need to turn your intensities way down, not to overexpose your scene. And now you can see we've got the same soft illumination as we had before. I just want to move it forwards here, just to show you. Just going to turn my intensity up a bit more, so you can see. And now you can see when we move them as well that they're very dependent on position. There will be no illumination behind the actual light source. You can see it's very, very bright here. So again, you want to work with your intensities. When you're working with large area lights, you want to make sure you're working at very low intensities. So you can see here when I scale it down that it goes a lot less bright. So that's the area light. So in this part we'll speak about directional lights, and how directional lights work is that they emit light in a direction that the arrows are pointing, and this light sort of loops around itself infinitely. So therefore directional lights are very good for simulating distant light sources. So if we look at the attributes here, we don't really have a lot of attributes to control our directional lights. We can do a render at default, and it will look like this, fairly overall bright. And if we can set them to emit diffuse or emit specular only, so we can see we'll have no illumination here because I don't have any specular materials. And if we set them to emit diffuse only here, you can see we're getting exactly the same results as we did before, because there's a complete absence of specular materials. So you can see there's no decay rate attribute here, and this is because directional lights are mainly to be used for simulating distant light sources. So if you think about a spotlight where the light's emitted from one end of the room to another, you would expect it to decay, but with something like light rays from the sun that's traveled really far already, you would not expect them to get any less brightened traveling through a room from one side to the other. So to simulate sunlight, you can set a nice warm color for your light, and you can set your intensities up high to 2 or 2.5, and this is a great starting point if you're trying to light up a room. You can see it's getting a nice warm color. And if we look at the directional lights as a light source, I just want to mention that they don't depend on position. You can see if we move them, it's got no effect, so you can place them anywhere in your scene, because this is because they loop around, so it doesn't really matter where you have them placed, you'll get the same illumination. You can scale them, won't make any difference to the illumination. And finally you can rotate them, and you can see this will make a difference. So depending on their angle, this is the only thing that actually matters to where the light will hit your surfaces. So for shadows, directional lights use depth map shadows and ray trace shadows. We spoke about this before, that their depth map shadows are not necessarily that good to use. You might want to stick with ray tracing. In this case, you can see we're not really seeing anything in our scene, and this is because I've got a window glass material applied here. We save this one, and I'm going to show you the material. I've got a Fong E here, and what I've done is that I've turned transparency up, and as you remember from when we spoke about depth map shadows, they do not calculate transparencies. So if you have a room with window glass that's transparent, you want to make sure you're using ray trace shadows. So we'll turn on ray trace shadows. And now you can see we're getting the windows casting shadows on the floor here. And you can see I've got a second window over here. So you can see here though that we're getting these light leaks, and this is because our geometry is built quite poorly. If you look at the depth map shadows here, the only illumination the room is actually receiving is from these light leaks. It should have been pitch black if we had good geometry. So this is something you want to think about when you're lighting up scenes and rooms. You want to be careful with different light leaks that can occur. So there's ways of fixing this. In my case here, because I have quite a simple scene, I don't really need to go in and rebuild my geometry. I can just set up blockers. So these are just large polycubes. And if I move these in here, they should help me block off the walls a bit and prevent the light leaks. You can see it's happening because I've got these really thin polyplanes that I've just put together. So this is why you're getting these light leaks. And you can see it's getting slightly better in that area than it was, but it's still not very good. It's still leaking a lot. So I've got a second blocker here. So if we move this one in, you should be able to see quite a bit of a difference. If we render this now, you can see here now the whole roof is completely blocked off as compared to here, so it's looking a lot better. So you can see we've still got some light leaks along here that you'd need to fix, so you'd need to move in more blockers to prevent these light leaks, or simply rebuild your geometry depending on how long it would take. So, but now we want to look at these shadows. We might want to go in and soften them a bit. So I'm just going to turn on a light angle, and I'm going to turn shadow rays to 10 only. You'd want to set this a bit higher, the light angle as well. But I don't really want to be here all day rendering with you, so now you can see we're getting some softness on the shadows. So you'd want to increase this, but I don't want to bore you with more render times. As you know, it's time consuming to render with ray trace shadows. But you can see this is a fairly good starting point for lighting up a room. You've got some shadows, you've got some warm light. You'd need to add a lot more light coming into the room. But you could use this if you wanted to do daylight. You'd simulate blue fill light coming in from the sky. If you were doing night, you'd do darker colors with more purple. You'd want to go in and fix your light leaks. But this is where directional lights can be very useful, so good to use for lighting up scenes and simulating sunlight or moonlight. In this part, we'll take a look at how you can merge your 3D model with a 2D background. So we're going to add a background here. You can see I've reposed the T-Rex. Got a number of lights. I've included the scene files, so you can go in and have a look where I have my lights, and you can see the floor here. We've created a floor plane. So right now we've got a Lambert on this one. So what we want to do is that we want to go in and we want to change this to a use background shader. And what this floor plane is going to do for us is that it's going to be where the T-Rex will cast its shadows, and this is what's going to kind of fuse the image together with the model, the fact that we'll have shadows casting. So you can see now when we assign the background shader, it goes black, and this is because this material is completely transparent. So when we put it up against our background now, you'll see that the only thing we'll actually see on it is the shadows. So we'll open up our camera. We're going to create a background here under environment, and I have this background, and here you can see our backgrounds appearing. And now we've got the floor plane here. I've obviously posed mine to match in with the background, so this is what you'll have to do. So if we go in now and we look at the background shader, in this case you want to make sure that there's no specular color or reflectivity, because where you're doing kind of a shady forest environment, if you were working with something like a reflective kitchen floor, you'd want reflections and specular highlights, but in this case we want to make sure that there's no specularity and no reflectivity. So you can see here we've got shadows falling on the ground here on our floor plane, and you can see this image is matching up pretty nicely If we didn't have these shadows here, it would look like the T-Rex was floating in the air. So this is why we need the floor plane with a background shader. So that's pretty much the end of this tutorial. I hope you've learned a lot about lighting in Maya, and I'll see you in the next tutorial.